All right, ladies and gentlemen, this video will talk about this concept of electric power. We learned that in the past that power is work over time, right? Now, work in electricity, which maybe we did, maybe we didn't do this, but voltage is basically work per charge. That's the definition of voltage, or the difference in voltage. Okay, so if I replace the work with V times Q divided by time, I can see that this quantity here is just the current, and this becomes V times I. So that's the formula for power. That's the one that we're going to use most of the time. So P is IV, okay? But it can also be written in terms of just V and R or I and R. Now we know that V is I times R. So this can become I squared times R. Or I can replace I with V over R. I hope everyone sees that. V squared over R. So these are the formulas we're going to be using for power. Now power, just like in mechanics, is in watts, as long as the current is in amps and the voltage is in volts. Power is also work over time. So it's basically the energy consumption over time. Now, when the electric company charges you, or the power company charges you for electricity, they charge you for per kilowatt hour. So the energy is basically P times T, but they charge you based on kilowatt hour. So power has to be in kilowatts, and time has to be in hour. So it's not kilowatt per hour, it's kilowatt times hour. That's another unit for energy. And we're going to do an example to show how to calculate the cost of electricity. So I'm going to keep that over here too. E is PT, or P equals E over T. Now, the brightness of a light bulb has to do with power. So a 100 watt light bulb is brighter than a 60 watt light bulb. Now, if V is constant, okay, maybe I should do if current is constant first. If current is constant, like in a series circuit, so kind of like it looks like this, and I have a bunch of resistors here, okay, the current is 1. Current going through each one of them is the same, because there's only one path for it to flow. So now which one is going to have, if these are light bulbs, so let's see which one is going to be brighter. So power is I squared times R. See how I went after what's constant? This way I don't have to worry about it. So the one that's going to be brighter is the one that's going to have more resistance. So high R means brighter. Okay. Now let's look at it if V is constant, and we'll do this when we do parallel circuits. So let's just take a bunch like this. This is a parallel circuit. What I mean by that is the voltage between this point and this point is the same as the voltage from there to there, is the same as the voltage from there to there, which is basically the voltage of this battery here. Okay? So if this is 9 volts, you will measure 9 here, 9 here, and 9 here. So if the voltage is constant, I'm going to do power is V squared over R, so it's easier to compare. Okay, so which one is going to be brighter? Low R is brighter. So you just have to be careful what kind of circuit you're dealing with. Okay, now I'm going to do an example here, and that should do it for this video. Okay, I say the power is energy consumed per time. Okay, So let's just say the example I'm going to use, if I have a 100 watts light bulb, okay, running for 10 hours a day at a cost of 8 cents per kilowatt hour. Okay, what is the yearly cost? Okay, so energy yeah, so energy is power times time, okay, and that's going to be equal to, the power is 100 watts, so it has to be changed to kilowatts. The time is is 10 hours, but I have to run this for a whole year, so 365 days. So it should be 365 kilowatt hour. So this is basically my time. Okay. So now to find the cost, you just do proportions basically. So you take your 365 kilowatt hour, you multiply by 8 cents, and should be getting 2,920 cents. Okay, or $29.20. So it adds up. So over a year, you're going to be spending almost $30 just for that light. Okay, and that's it for this video. See you later.